In this video, we're going to deepen ourselves more in experimental probability. We're going to do that with an example. So as an example, Leandro plays for Los Angeles Lakers, and last week he had to take 10 free throws during a game, and he succeeded 8 times. And you have to find the probability that he succeeds the next time. So we can see the game as an experiment. And he succeeded 8 times. So the absolute frequency, or just the frequency of success, is 8. So the absolute frequency, that means like the number of times he succeeded. So the absolute frequency of success is 8. So the number of trials, in this case, he tried like 10 times, is 10. So the number of trials in this case is 10. So he succeeded 8 times, he tried 10 times, so he failed 2 times. So we can say that the absolute frequency of fail is 2. Because he failed 2 times. Is 2. Okay. We can also find the relative frequency of success and the relative frequency of fail. Let's write that down. The relative frequency of success and the relative frequency of fail. We are going to see that in the next part more in detail, but we can introduce it here already. The relative frequency of success is the absolute frequency of success, so the number of times he succeeded, which is 8, over the total number of trials, so the amount of times he tried. So he tried 10 times. So in this case, it is 8 over 10. Over 10. And the relative frequency of fail is again the absolute frequency of fail, so the number of times he failed, which is 2, over the total number of times, like the total number of times he tried. So the number of times he tried, 10. So it's going to be, in this case, 2 out of 10. Okay, if we look at those numbers here, we see, and it makes sense as well, that the absolute frequency of success, which is 8, plus the absolute frequency of fail, which is 2, so 8 plus 2, must be equal to the number of trials. Because like he tries 10 times, he fails 2 times, and then he succeeds 8 times. So 8 plus 2 must be equal to 10. For the relative frequencies, so you can either succeed, or fail. So the relative frequency of success, which is 8 over 10, plus the relative frequency of fail, which is 2 over 10, must be equal to 10 over 10, or 1, or 100%. Okay, let's go back to what they ask in the example. They actually ask the probability that he succeeds the next time. So the experimental probability in this case. To find this, we use the experiment. We use the results of the experiment. Here we find out that the relative frequency of success is 8 out of 10. And they ask the probability that he succeeds the next time. So we say that it's equal to 8 over 10. So in other words, we use the relative frequency in this experiment to estimate the probability of the corresponding event. So let's write that down. We use the relative frequencies of an experiment to estimate the probabilities of the corresponding event. So for this example, the probability that he succeeds the next time is 8 over 10, or we can also say 80%, or we can also say 0.8. And the probability that we just calculated is the experimental probability, because we calculated this probability by observing the results of the experiment. Let's check another example, example 1 in our book. So we see here Larissa took 43 shots at the netball goal and scored 29 times. You have to estimate the probability that Larissa will miss with her next shot. Okay. So he scored 29 times and he took 43 shots. So we can say that the number of trials is equal to 43 because he tried 43 times. And the absolute frequency, or just the frequency of scoring, is 29 because he scored 29 times. So the absolute frequency of success, you can say as well. So the absolute frequency of scoring, let's say, is 29. Okay. Out of this information, we can say that the absolute frequency of not scoring, so in other words, missing, must be equal to the 43 here minus the 29, because she tried 43 times, succeeded 29 times, so she failed 43 minus 29 times, so that is 14 times. So we can say the absolute frequency of missing is 43 minus 29, which is equal to 14. Okay. We can continue with two different methods. Let's say the first method. In this case, we can find the relative frequency of missing. So the relative frequency of missing is equal to the absolute frequency of missing, which is 14, over the number of trials, 43. So it is 14 over 43, and that is the answer. Okay. Or we can use a second method. can first find the relative frequency of scoring. Which is 29 here, the absolute frequency of scoring, over the number of trials. So that's going to be equal to 29 over 43. And to find the relative frequency of missing, we can do 1 minus 29 over 43, because we've seen that the sum of the relative frequencies must be equal to 100% or 1. So the relative frequency of scoring plus the relative frequency of missing is equal to 1. So we can say that the relative frequency of missing is equal to 1 minus the relative frequency of scoring. So that's going to be equal to 43 minus 29 over 43. And 43 minus 29 is 14. So it's 14 over 43. It's the same answer as here.